Okay, so now let's look at hash table big O. I'm going to bring up a hash table like this. I'm going to use linked lists instead of the nested lists that we've done so far. And the only reason I'm doing it this way is it's visually easier to look at. And I'll bring up our hash method here. So since everything we do with the hash tables involves using this hash method, the first thing we need to do is figure out the big O of the hash method itself. So for a given key of a certain number of letters, it will always be the same number of operations to calculate the hash. That means that the hash method itself is O of 1. So now let's look at setting an item. We run it through our hash method, and let's say that's going to be at the address of 2. We append that onto our linked list like that, and appending that is also O of 1. Now let's look at get. We'll say get item screws. That's going to give us the address of 6. It was O of 1 to find the address, and then one operation to find screws. But what if our hash table looks something more like this? Now when we say get item screws, it's O of 1 to find this address, but then we need to iterate through the list until we get to screws. So it would seem that the worst possible scenario would be that all of these items would be put at the same address, and we would have to iterate through all of them, and it would be O of n. But the assumption with a hash table is that the distribution is going to be more like this. Even with the very primitive hash method that we created, it gave us a very good distribution of these items. The hash method that's built into Python is going to be even more efficient at distributing all of these items. And also, you're going to be dealing with a much larger address space. So collisions are going to be fairly rare. So we treat hash tables, which are implemented as dictionaries in Python, as O of 1. And it is O of 1 to place a key value pair or to look up something by key. Either way, it is O of 1. And that is our quick overview of hash table big O.